Hello everyone, my name is Garima. Welcome back to my YouTube channel Crack CSA Exam with Ease. I hope you have found my previous video in which I have discussed previous year questions of March 2026 physics. Now in this video I am going to discuss next 20 questions. Now let's start with the question number 21. When an object is in equilibrium, it must be A. With zero velocity, B. With zero resultant force from concurrent forces at rest, moving in a straight line with a constant velocity. We know that when object is in equilibrium, that means the net force acting on the object is zero. So according to this, option B is correct. Question number 22. As shown in the figure, a block moves a distance x horizontally towards right under the force F at an angle alpha to the horizontal. The work done by force is. Here the force F is making angle alpha with the horizontal. We know that work done is equal to F dot S, where F is force and S is displacement. And uh, this the angle between force and displacement is alpha, so the component of force along displacement will be F cos alpha. We will put the value of force and displacement, that is F cos alpha, into x, so work done will be Fx cos alpha. Option B is correct. Question number 23. The diagram correctly shows the velocity and acceleration direction of a projectile. We know that in projectile motion the acceleration is due to gravity, and it is always towards downward. So in option A and option B, the acceleration is in the downward direction and velocity is always given along the tangent of the path. So according to this, option A is correct. Question number 24. A light spring with its elastic limit produces 8 Newton of force at a 4 centimeter extension. When compressed 1 centimeter, its force is. We know that according to spring force, force is equal to kx, where k is spring constant and x is displacement. So k will be equal to F by x. We will put the value of force, that is 8 Newton, and displacement, which is given as 4 centimeter. We will convert that to be in meter, which is equal to 4 into 10 raised to power minus 2. Then we will get k is equal to 200 Newton per meter. Now we have to calculate force when compression is 1 centimeter. So force is equal to kx, and we have already calculated k. We will put the value of k, that is 200, into displacement, that is the compression, which is 1 centimeter. We will convert that to be in meter, which will become 1 into 10 raised to power minus 2. When we solve this expression, then force will become 2 Newton. So option D is correct. Question number 25. A certain mass of ideal gas with its temperature kept constant and pressure reduced, its volume is. According to ideal gas equation, we know that PV is equal to nRT, where P is pressure, V is volume, N is number of moles, R is gas constant, T is temperature. Here temperature is given as constant, so PV will become constant. So as we increase the volume, the pressure will decrease, or as we decrease the pressure, the volume will increase. So according this, option D is correct. Question number 26. A resistor of resistance R has voltage V applied across it. The graph of charge Q passing through its cross section versus time has a slope representing. Here graph is given between charge and time. We know that slope of QT graph gives you current. So I will be equal to Q by T. And from Ohm's law we know that V is equal to IR. So I will be equal to V by R. So according to this, option B is correct. Question number 27. For a single turn coil with the magnetic flux decreasing uniformly by 2 Weber each second, which of the following description is correct? According to Faraday law, we know that EMF induced in a coil is equal to negative of change in flux with respect to time. Here the in decreasing flux is given as 2 Weber, so it will become minus 2, and time is given as 1 second. So EMF will be 2 volt and this value is constant. So according to this, option B is correct. A light ray strikes a mirror at 30 degree as shown in figure. The angle of reflection is, since here angle is given as 30 degree with respect to the horizontal. So we know that of incidence is always calculated between the normal ray and the incident ray. So it will become 90 minus 30. So angle of incidence will become 60 degree. According to law of reflection, we know that angle of incidence equal to angle of reflection. So angle of reflection will also become 60 degree. According to this, option D is correct. Question number 29. In vacuum, points A and B are at a distance of r and 3r from charge q respectively. The ratio of their electric field strength is. Here, charge q is at a distance of r. So according to this, uh, electric field at point A will be kq by r square. And in next case, the charge q is at a distance of 3 times r. So according to this, electric field at point P will be kq by 3r whole square. It will become kq by 9r square. When we take the ratio of EA by EB, it will become 9 is to 1. So option D is correct. Question number 30. In a uniform electric field shown in the figure, a thin rod AB of length L makes an angle theta with the field. The potential difference between the ends A and B is. In uniform electric field, we know that change in potential is equal to E dot dl, or length. Here, the change in potential will be equal to electric field and the length parallel or in the direction of electric field. So the length A will become L cos theta. So according to this, change in potential difference will be equal to EL cos theta. So option A is correct. Question number 31. As shown in the figure, a ray of light enters the surface of a glass with the refractive index n is equal to root 2 from air. Total internal reflection would occur when the angle of incidence exceed. The necessary condition for total internal reflection is that the light ray must travel from denser medium to rarer medium. But in the question, it is given that light ray is going from air to glass, that is from rarer to denser. So this TIR phenomena will not be occur in this process. So option D is correct. Question number 32. The PT graph of certain gas is given below. From the graph, the volume of gas is. According to ideal gas equation, we know that PV is equal to nRT, and then P will be equal to nR by V into T. Here nR by V will be slope. So here volume is inversely proportional. That means the volume first it becomes constant and then starts decreasing. So option C is correct. Question number 33. 2 point charges are separated by a distance. If distance between them is increased by 3, then Coulomb force between the charges will be. Here two charges are given, Q1 and Q2. They are separated by a distance r, and so according to Coulomb force, force will become K into Q1 into Q2 divided by R square. Now in second case, if the distance is increased by 3R, so Coulomb force will become K into Q1 Q2 divided by 3R whole square. So the force will become 1 by 9 of the previous force. That means option D is correct. Question number 34. As shown in the figure, there is a electric charge in the space with 2 points A and B. Which of the following statement is correct? Here in the diagram, I have drawn two regions, that is region 1 and region 2. In region 1, the electric fields are crowded. So here the strength of electric field will be higher. And in region 2, electric field lines are far from each other. Here the strength of electric field will be low. So according to this, strength of electric field at point A will be greater than strength of electric field at point B. So option C is correct. Question number 35. Figure A shows the coil used in Faraday's electromagnetic induction experiment. The working principle is shown in figure. Which of the following does not cause the pointer of ammeter to deflect the experiment? Here two figures are given. Figure A, in which a circular coil is given, and in figure B, two coils are given, primary coil and secondary coil. When the switch is on, then the current through primary coil will increases. That will lead to increase in flux. So according to this, there will be induced EMF in second coil according to Faraday's law. So when we adjust the rheostat, that means the resistance of the wire is changing. According to this, the current is also changing. So it will lead to a change in magnetic flux. So according to this, the ammeter will deflect. When the when closing the switch, when the switch is closed, the potential will rise from 0 volt to 5 volt. That means here the current is increasing or potential is increasing, so the magnetic flux linked with the primary coil will also increase, and that will lead to increase in flux in secondary coil. So there will be induced EMF in secondary coil. Or when we open the switch, the EMF will reduce from 5 volt to 0 volt. In this, the potential difference is decreasing, so it will also cause to induced EMF in secondary coil. But in D option, keeping the switch closed, when the switch is closed, the EMF will become constant and there will be no induced EMF in secondary coil. So according to this, option D is correct. Question number 36. In free fall, let EP be gravitational potential energy and h be the distance fallen. Use the horizontal ground to be zero potential. Which of the following graph correctly shows the relationship between EP and H? Here, suppose let capital H be the total height and H be the distance object has already fallen. So, according to this, current height will be H minus H. So, gravitational potential energy will become mg into H minus H. When we solve this, this equation will become y is equal to mx plus c, where m represent the slope. Here slope is coming to be negative. So according to this, option A is correct. Question number 37. As shown in figure, and mass 10 kg object remains stationary on a rough horizontal surface under a horizontal forces F1 is equal to 18 Newton, F2 is equal to 10 Newton. If the coefficient of friction is mu is equal to zero point 0.2, the frictional force on the object is, here G is given as 10 meter per second square. Here two forces are given, F1 18 Newton which is acting in right direction and F2 which is 10 Newton acting in minus x direction. So the net force will be 8 Newton which is towards right direction, and there will be two other forces, that is the normal reaction and mg, and these two forces they are balancing each other. So the friction force will be opposite to the direction of motion, that will be in negative x direction or towards left direction. So maximum friction force is equal to mu times n, where normal reaction is mg. We will put the value of mu, that is zero point 0.2, mass that is 10, and g is equal to 10. According to this, the maximum friction force will be 20 Newton. Since object is remains at rest, because friction force 20 Newton is greater than 8 Newton. So the friction force will become equal to the net force, that is 8 Newton, and it is towards the left. So according to this, option D is correct. Question number 38. An object of mass m falls from a rest with a constant air resistance, achieving an acceleration 4 by 3. When falling a height h, its mechanical energy loss is. Here the object is falling towards ground. So the gravitational force will be mg, that is acting in downward direction, and resistance force due to air, that will act in upward direction. So according to uh, so we know that force is equal to mass times acceleration. Since object is moving in downward direction, that will become mg minus f will be equal to mass times acceleration. Here acceleration is given as 4 by 5g. So the friction force F will become mg minus 4 by 5 times mg. So friction force will be equal to 1 by 5 times mg. Here we need to calculate the total mechanical energy loss. The energy loss is equal to, we can say that it is equal to work done, which is equal to force times displacement. And here we are calculating energy loss due to the friction force, which is equal to 1 by 5 mg, and distance is h. So according to this, option A is correct. Question number 39. In the following diagram, the arrows represent electric field lines. Which of the following statement is correct? Here, four diagrams are shown. Option A, diagram C shows the field of two equal negative point charges. Here, diagram C represents the two positive charges, not the opposite charges. So, this option is incorrect. Diagram B shows the field of two equal but opposite charges. Okay, this is the diagram which represents the positive and negative charges. But I have drawn a diagram where you will see that in negative charges the field lines are going inside, or moving towards the center. So this diagram B is also wrong. Option A, option C, diagram A shows the field of negative point charge. So here the charge is given as positive and it is the electric field due to a positive charge. So this is also wrong. In option D, diagram D shows the field between two plates of charged parallel plate capacitor. So this diagram represents the uniform electric field due to the parallel plate capacitor. So according to this, option D is correct. Now move to our last question, that is question number 40. As shown in figure, if two objects A and B with equal masses are placed on a horizontal disk rotating uniformly around the vertical axis, and the two objects remain stationary relative to the distance, then here a disk is rotating with the same angular velocity omega. So angular velocity at both the points A and B will be equal, but the linear velocity will be different because the distance of mass A from axis is greater than the distance of mass B from axis. So according to this, linear velocity at point A will be greater than linear velocity at point B. So according to this, option C is correct, that is the angular velocity at both the points are equal. That's all for today's. uh, I think you like the video. Please follow and subscribe my channel.